Welcome to The Future and You. Ideas and opinion about the future based on verifiable facts of today. This episode is for March 25, 2015. I am your host, Stephen Euin Cobb. This is the 400th episode of The Future and You. Joining me to discuss many different futuristic topics is Nancy Kress. Aside from being a science enthusiast like me, Nancy Kress is the author of 32 books, including 25 novels, 4 collections of short stories, and 3 books on how to write better. Her work has won 5 Nebulas, 2 Hugos, a Sturgeon, and the John W. Campbell Memorial Award. This interview was recorded using Skype on March 19, 2015. And now, on to our interview. Here is Nancy Kress.
Well, first of all, thanks for sending in a prediction for my 200th episode, and then again for my 300th episode. Lately, I haven't been keeping close attention to the numbers, and so I didn't realize and did not send out a call for predictions for the 400th episode. So congratulations, you will be in it. This is the 400th episode.
That's a lot of episodes.
Yeah, it is. Yeah, it's been years since I talked to you, so I have lots of questions. Let me start off, Let me start off with genetics, because, of course, that's something very close to your heart. Decades ago, solving for a genetically caused disease meant protecting people who were not yet born or conceived. But things have changed. Genetic editing with precision has become possible in the last couple of years. If you would, talk about that a little bit.
Tell me exactly how you're using the term genetic editing.
Well, nowadays, Wikipedia actually has an article with the heading Genetic Editing because of the ability to precisely slice the double helix and then insert material so that this can be done with accuracy. And my understanding is it can now be done not just in one cell, but in multiple cells using techniques that I don't remember the name of.
Okay, first of all, a disclaimer. You know that I'm not a scientist.
Yes.
So what I know about this is what I have read about it. And when you're talking about removing some section of DNA or some specific gene of DNA and replacing it, there's 2 different ways that this applies. One is to the embryo. And we do this all the time with mice. We create knockout mice in which the genes that control the immune system have been knocked out so that we can have mice without immune systems in order to give them various diseases and check the results of giving medications and drugs on them. So we know how to do this. We don't do it with people yet. Do I think we'll eventually do it? I wouldn't rule it out. I really wouldn't. This very much is playing God, or at least evolutionist, with our own destiny. But we don't do it yet. It's not a thing that we do. The other use is in gene therapy for getting into cells specific genes and getting that will aid the solving of genetic problems. And this is still something, as far as I know, that's in its infancy. Putting in a specific gene, we can inject it into the cell, but we don't exactly know where it's going to land unless we take the cell out and then we can splice it into that particular DNA, but that doesn't mean that it's automatically going to get into the other DNAs, the other cell's DNA. So this is something that's very much, as far as I'm aware, at the beginning of where it could go. Where it could go could be very exciting in terms of curing diseases.
Do you feel mostly good about it, or maybe mixed feelings? I mean, some people, they hear these kind of words and they think, oh, that's scary stuff.
It is scary, but I feel mostly good about genetic engineering in general. And I know that in the United States, this puts me in a rather small minority because we have a great deal of fear of genetic engineering here. Right now, my city, Seattle, is wrestling with questions of labeling and genetic engineering of salmon. A genetically engineered salmon will grow larger and produce more meat and do it faster. But a number of supermarkets have stated they will not carry these. I come down squarely on the side of genetic engineering in all 3 levels. The first level is bacteria. And we are doing this. And usually people don't object to this because they don't know about it. Almost all of the insulin that's produced now is from bacteria that have been modified genetically to produce this insulin. And it used to be much more expensive for people who need insulin for diabetes because it had to be extracted from the urine of animals. And now bacteria make it. And again, people don't usually object to this because partly they don't even know that it's going on. But there's some very exciting things about the genetic engineering of bacteria going on. There is a Japanese group of researchers that is hot on the trail of engineered bacteria that will eat certain kinds of wastes that are produced by oil spills. This would cost about a tenth to clean up oil spills if we can get this that they currently have. The second level up is the genetic engineering of crops. And of course, this is the big one as far as causing controversy. William Safire, not a person I ordinarily align with, but he had a wonderful phrase for the European attitude towards the genetic engineering of crops, which is, they call them frankenfoods over there. And Safire said there is a monstrous prefix stalking Europe. We have genetically manipulated crops for centuries. There is now no corn that is not a hybrid. Yes, it is done with conventional in quotes, methods for crossbreeding. But corn can no longer reproduce by itself because we have crossbred it and created these hybrids that are sweeter and plumper and better to taste. Genetic engineering merely speeds this up by precision targeting of certain genes out and other certain genes in. And yes, there are dangers, but there are dangers with everything in technology. The first day that man discovered fire, the crime of arson became a possibility. And although in the United States we may have the luxury of choice, saying, well, I don't want my food genetically engineered, much of the world does not have this choice. And as population grows, in order to feed maybe even ourselves, but certainly the third world, we are going to need to rely on genetically engineered food. There's a woman named Florence Wamsutta who wrote a long article on this. She had worked in Kenya with the Kenyan government at a conventional crossbreeding of plants facility to try to develop a sweet potato that was immune to a blight, a local blight, sweet potato blight. She spent 10 years trying to do this in Kenya, and they couldn't succeed. She then moved to England and joined a British biotech firm, and within 2 years, they had developed the sweet potato that was resistant to this blight, thereby saving countless numbers of lives and making people better nourished. This is something that if we're going to feed the world's population is going to have to come. And to some extent is already here. If you had a pastry today at all, then the canola oil in it with which it was probably made is probably Canadian, and it is probably genetically engineered, because Canadian, almost all the rapeseed canola plant that Canada uses is genetically engineered. If you wore something with cotton on it today, the cotton was probably genetically engineered. The soybeans in anything which might have been in your pastry or in any number of things are most likely genetically engineered. For Europe to say we're not going to accept this and bar imports of it is not only short-sighted, but in my view, it's hypocritical. For instance, the French don't allow the importation of Canadian canola oil. But the bacteria that produce some of their cheeses and wines, the wines, are genetically engineered. And they claim that it's because it's a interim process. It's not the final product. It's not the same. But there have been studies that show that some of that genetically engineered DNA ends up in the final process. Whereas with the canola oil, the high heat used in order to create the canola oil, to purify it, destroys the DNA of it. So you have to wonder if this is trade protectionism or if it's actually an idealistic crusade.
Yeah, it sounds kind of like maybe they have latched on to a fear that the public already has and uses it to their own economic benefit.
Yes. And the next step up from crops is animals. And again, we've already genetically engineered these as well. There are cows that produce more milk. There is now a goat somewhere in the West or Midwest that is producing milk that contains spider silk. There are also more frivolous uses. If you want to buy a rabbit that glows in the dark, you can, because it has jellyfish genes spliced in it. I don't know why you would want a rabbit that glows in the dark. But Stephen, if you want one, you can have it.
So I can find it in the dark.
And I think under the bed. And I think that all of this, as we go forward, it will become more accepted. Then the final level, of course, is genetically engineering of humans. And I have to say that in one sense, although we are not yet fooling around with human embryos in the sense of taking genes out of them and putting genes in, but we do have a selection process going on. If you have a baby that's an egg that's fertilized in vitro, and 60,000 in the United States are every year, let's assume that you're an infertile couple and you go in and it's your husband's sperm and your egg, and it's done in vitro, and you end up with 8 embryos. And 4 of them have markers for genetic diseases, which we scan for, that are inherited in your family, which is why you're doing this in the first place. So you don't want those 4. Of the 4 remaining embryos, let's say you wanted a boy and 3 of them are male. Okay, you now have a boy. We can begin to look at some of the other genes that we know where they are, or we will be able to very shortly. You'll be able to say, okay, these are the genes that we think contribute to height, and we think that 2 of these guys are going to be tall and 1 is going to be very short. 5'2" is not a disease, not even for a boy, but neither in our society is it desirable. So you pick one of the embryos that isn't indicating, the genes indicating that it's going to be short. This kind of thing is already going on. I don't know to what extent, but I do know that it is because people have told me so. And it will only go on more so as we go along. This is a kind of genetic engineering without actually touching the genes that are in the embryo itself. It's already happening, and if there is a profit angle for it, if there is an advantage that would-be parents think they can have for their prospective children, then it will happen. If it doesn't happen here, it will go offshore. And this is all what Beggars in Spain, of course, is about, my whole trilogy, about the question of genetic engineering humans. This has been a very long answer, I know.
I know, yes, but it's excellent stuff.
The question was, am I in favor of genetic engineering? And I have to say, yes, we need some controls, but we should also understand that once the genie is out of the bottle, you can't put it back in.
Mm-hmm. Speaking of Beggars in Spain, describe for the listeners exactly what part genetic engineering played in it.
In Beggars in Spain, people are genetically engineered to not need to sleep. We don't know how to do this. We don't know what genes contribute to sleep, although we're finding out more and more what brain structures are involved. But I wrote it partly because I wanted to write a book in which there is genetic engineering going on that doesn't produce monsters or vastly deformed people or any of the other things that science fiction has so often done. Especially they do it with clones, which is just delayed twinning. Well, my book is not about clones. But I wanted to create a genetically engineered change to human brains that has no downside. The problem with that, of course, is then you have no story because you have no conflict. So the conflict comes in from the reaction of everybody else, the normals, people who do need to sleep, to the genetically engineered people who don't, who have an evolutionary advantage, which is the other reason I wrote this book. I'm a long sleeper, and I resent it. I have friends who can get by on 6 hours a night, and they get more life than I do because I have to have 8.5, or I'm just a mess. And I resent it, so I wrote it out of envy.
One would think that not needing sleep is a small change, but if you get a sudden 8 hours a day extra of your life, that's a big, big change.
Yes, it is. My major character, Elisha, goes to law school. And law students, like physicians students, are perpetually short of sleep and perpetually need to study more and perpetually learn to learn more. And she has a big advantage there.
Yeah, the world is really designed for people who are going to be sleeping for 8 hours every day. And so, yeah, those bonus hours could really change your life.
Yeah. I want them. I'm not going to get them, but I want them.
Okay. Let me ask you about stem cell research. as well as treatments. What's your take on that? What's going on now, and maybe a little bit about what we can expect for the future?
We're having a minor brain drain, as you probably know, in the United States because we don't permit enough stem cell research, and we have lost some key researchers to England where more of it is permitted. This is so much a religious question and in some people's mind a moral question, whether or not it should go forward, that it's really not something that I can talk about in terms of ethics, because it comes down to a religious belief, and that pretty much isn't arguable. You either do or you don't. As far as the value to be gained from it, I think could be tremendous value in terms of coaxing embryonic cells, stem cells, that haven't yet decided what organs they're going to be into being what organs we want them to be. They've hit some roadblocks on this. They may not be as malleable as we had originally hoped, but there still hold out a lot of possibility.
You are a member of Sigma, the science fiction think tank that helps government agencies think more creatively about possible scenarios and solutions. I've interviewed a number of people who are also in it: Ben Bova, Jerry Pornell, Catherine Asaro, Charles E. Gannon. I'm curious, how did you come to be in it, and what kind of activities does the group actually do that you have been a part of?
I am involved in it, but I'm not involved to the extent as the names you just made, because as you probably know, they're all scientists and I'm not. Well, actually, I don't think Chuck Gannon is, but the others all are. I got into it because I was invited to do so, because it seems a worthwhile thing to do. And the conferences that I participated in have talked about possible future scenarios in science as envisioned by science fiction writers, so that various branches of the government can use them. I can't say too much about this, you understand, Stephen. Can use this to make future plans.
Mm-hmm. Yeah, I imagine some of the agencies are military or maybe even intelligence, so there are limitations on what you're allowed to say, I'm sure.
Yes.
Yeah. I am curious, though, if you can answer, what does the participation actually involve? I mean, do they phone you? Are there conferences, or are there meetings? Or are they you alone, or is it a whole group of members?
Again, usually the ones I've been involved in have been a group. There may be individual phoning going on that I'm not aware of.
Okay. I won't press you on it. I don't want to get you in trouble. Let me ask you about, of course, you're familiar with the famous DARPA challenges. They ran a new set just recently in the last, I guess, 2 years. Are you familiar with this recent DARPA challenge?
I read about the one involving robots. Is that the one you mean? The robots that can carry things?
Mm-hmm. Yeah.
Yeah, I've seen some of the results online. They're really fascinating.
Yeah, I followed the first two. Well, I say I followed them. I watched documentaries about them long after they were over. There was one in 2005 where the robots were they were robotic vehicles, and all they had to do was follow a course. It was a very complicated, difficult course, and the first year nobody finished, even though there were 27 or 42 participants. None of them were able to complete I think it was a 42-mile course out in the desert. Then the second time they did the same similar course, and I think 5 vehicles finished. And then the next time they did an urban challenge where they were in a sort of a city street type or a suburban street type thing, and the vehicles had to negotiate stop signs and red lights and things like that. And I don't remember the results of that one. This recent one the goal is to make a human-like, not necessarily looking like a human, but a human-like robot that could negotiate or navigate through a disaster area, like a hurricane had come through, or the Fukushima nuclear disaster, that kind of place where a human shouldn't be. And I watched some of the video, and some of it was really good, but some of it was almost laughably bad. I mean, kind of sad and pathetic about how poor the robots were doing, just trying to open a door or things like that. Naturally, this is early days. I'm sure that, naturally they'll get better and better. What is your thoughts about robots as far as either now or going forward into the future?
I think that they're going to be enormously important in doing just exactly the kinds of things you're talking about. And that the technical problems of getting them to move like humans or like animals. The one that I saw an impressive video of was a mule it didn't have a head, but it had 4 legs like a mule, and it could carry a lot of very heavy equipment over a rocky terrain. And if it fell over, it was able to get up. This is a big, big step forward because they didn't used to be able to get up. And I think that this kind of robot has got tremendous potential for contaminated areas, for disaster areas, for the carrying of heavy burdens into war zones. The other kind of robot, the AI, this isn't something I know a lot about. But I don't see in the near future robots that can control themselves that way.
If we think farther into the future, if we imagine farther into the future, what are your thoughts for AI as far as reaching human level and maybe surpassing it?
You know, Stephen, I honestly don't know. I keep hearing people like Werner Vinge talk about the singularity when we reach this point. And then I hear other people say, no, it simply isn't possible because the human brain is not a computer analog. It's sui generis, and you can't reproduce it by trying to have on-off binary systems, which the computer basically is. I don't know. I really don't know. I don't think that science fiction is in the business of predicting this is going to happen or this is going to happen. What they are in the business of doing is rehearsing the future. This could happen. If it does happen, what are the implications? This could happen. If it does, what are the consequences? Sometimes there are things we don't even want to have happen or that we would never engineer, but they're to highlight a specific aspect of what it is to be human. For instance, I'm thinking of Ursula Le Guin's Left Hand of Darkness, in which the characters she's created are both male and female. They have 2 sets of sex organs, and at any time, anybody can become pregnant, anybody can become a father, and they don't know what's going to happen. And nobody is planning on making people like this. It's probably not even a great idea to make people like this. But the reason that Le Guin says she wrote this book is to highlight the question, what does it, when you subtract gender, what's left? What part of humanity does not depend on being able to have a gender identity? And I think some science fiction does this. Other science fiction, including some of mine, is more a rehearsal for this could happen. If we go on doing this, or we go on doing this, or we go on doing this, this is the result that could happen. But that doesn't mean that it will happen or that we have any idea that it's going to happen. And when you say to me, what do you think will happen with AI in the far future? The only honest answer is I haven't got a clue.
Okay.
Michael Faraday took some electrical experiments to Queen Victoria in the 1800s because she wanted to see what this new stuff was, this electricity. So he set up his experiments in the royal presence, and he performed them. And Queen Victoria watched with her usual impassivity. And then afterwards she says, yes, but Mr. Faraday, what good is it? And he said, Madam, what good is a baby? You don't know what it will grow up to be. We have no idea what robots or AI will grow up to be.
Sort of a robot-y topic would be self-driving cars.
I want one.
You want to be able to read your book on the way to where you're going?
I'm not a confident driver. I read somewhere that 70% of Americans rate themselves as being above average as drivers, which is statistically pretty interesting. I'm in the other 30%. I'm not confident. I frequently find myself in the wrong lane. I don't mean heading the wrong direction, but in the wrong lane to make a left turn or a right turn or whatever turn it is I'm trying to make. In Seattle, which is a particularly challenging city to drive in, there are bus lanes all over the place. There are streets that just end in cliffs and resume at the bottom.
Yeah.
There are bodies of water lying around in the middle of the city. I'm not a confident driver. A car that drives itself would be absolutely wonderful.
Yeah, Toyota has already announced, almost a year ago, they announced that their 2020 models will include a large number of self-driving cars.
2020. Okay, I'm going to start saving my pennies.
Yeah, I'm kind of looking forward to it. My suspicion, and I'm just guessing, is that if they are far safer than human drivers, one of their advantages, by the way, is that their response time, the reaction time, would be somewhere around 10,000 times faster hitting the brakes than a human being. And so they would be much less likely to run into something or for something to run out in front of them and then them to hit it. My suspicion is the insurance company is going to love it and lower your rates if you have one, or charge you extra if you don't.
It all sounds terrific. Let them charge me extra. I'm still willing to do it.
That was Nancy Kress. You can learn more about Nancy Kress using the links I've placed in the show's blog post, which is located at thefutureandyou.libsyn.com. Libsyn is spelled Libsyn. That's it for this episode of The Future and You. This program is licensed under the Creative Commons Attribution, Non-Commercial, No Derivative Works 2.5 license. A copy of this license may be viewed at creativecommons.org. Briefly, this means you may, indeed you are encouraged to, copy this entire program as many times as you wish and give it away to as many people as you wish. But you may not copy only a portion of this program, you may not charge anyone any amount of money for it, and you may not use any portion of it to make something new. On the other hand, anyone whose obvious goal is to recommend the show to others automatically gets special dispensation. Offline reviews, which include the show's website, may include brief quotes. And online reviews, such as for a blog or community group or web page, which provide a conspicuous link to the show's website, may use as many quotes as they wish, up to and including a transcript of 1/2 of any interview. The show's theme music is a blues number called Some Sympathy by Chris Jurgensen and is from his album Big Bad Sun, which is available at magnatune.com. Magnatune is an independent record label that sells its catalog of music through online downloads and print-on-demand CDs. The company allows artists to retain full rights to their music and splits equally with an artist all the revenue from the sale of their work. All the music at Magnatune may be previewed free of charge, and customers can even choose how much they want to pay for the music, with pricing ranging from $5 to $18 per album. You can learn more about them at magnatune.com. That's spelled magnatune.com. If you have a theory or opinion about what the future will contain, be it the near future or the far future, you may email it to me at thefutureandyou.com. That's thefutureandyou.com. You may also suggest topics that you would like to hear discussed, or send contact information for experts that you feel might provide valuable insights into the future. Mind you, an expert is not necessarily someone with an impressive degree. The best experts are the people who live or work or strive in the area under discussion. If the subject is science or medicine or academia, a degree is important, but if the discussion concerns trends in construction or firefighting or video gaming, a degree is pretty much meaningless. To get the inside dope, you've got to find the people who actually do this stuff every day. They are the first to see the trends because the trends have already begun changing their lives. As to the topics we will explore in the next episode of The Future and You, I can make no guarantees. Interviews are still being sought, recorded, and edited. All I can promise is that we will ruminate on the future. To learn more, check the show's website at thefutureandyou.com. If you enjoyed the program, please mention it to a friend, and be sure to join me again next time. Until then, I have been your host, Stephen Euin Cobb. On behalf of myself and all my guests, I thank you for listening.